Good morning, champs. In this video, we continue with the same type of heating problem. Before, we use Cp times delta T, but is that always the full story? Let's include the pressure term and see how much it matters. Water flows through a pipe. The mass flow rate is 0.6 kilograms per second. The water enters at 20 degrees Celsius and leaves at 60 degrees Celsius. The heat capacity at constant pressure is 4.18 kilojoules per kilogram Kelvin. Now we also include a pressure drop of 0.1 bar, and we use a specific volume of 0.001 cubic meters per kilogram. We start again from the energy balance. It includes heat, work, and energy carried by the flowing mass. Now we simplify. The process is steady state, so the energy inside does not change over time. There is no turbine and no compressor, so there is no shaft work. And we have one inlet and one outlet, so the heat flow equals mass flow times the change in enthalpy. That means everything depends on the enthalpy change. For a liquid, the enthalpy change can be approximated by two terms. The first term is Cp times the temperature change. This is the temperature effect. The second term is specific volume times pressure change. This is the pressure effect. And notice that we use Cp here, not just any C. Why? Because we are calculating an enthalpy change. If we were dealing with internal energy at constant volume, we would use Cv, but here we use Cp. Now let's compare the two effects. The temperature change is 40 Kelvin, so Cp times delta T gives about 167 kilojoules per kilogram. Now the pressure term. The pressure drop is 0.1 bar, which is 10,000 Pascal. Multiplying by the specific volume gives about 0.01 kilojoules per kilogram. So compare these numbers. The temperature effect is about 167 kilojoules per kilogram. The pressure effect is only about 0.01 kilojoules per kilogram. That is extremely small. So now we see why we usually ignore the pressure term for liquids. But the important part is not just ignoring it. The important part is checking its size. For liquids, Cp times delta T usually dominates, and now we know why.